Hello, everyone. This is Yamina from DrGPCR, and welcome to the December edition of the DrGPCR monthly newsletter. This is the first year that we've been doing this video recording. I don't think we missed any, or maybe we missed one, so people are enjoying it. And today I'm delighted to have with me Dr. Terry Kinakin. Terry, welcome.
Thank you, Yamina. I'm happy to be here.
Very excited to have you here because you and I have great news to announce. So we are launching at DrGPCR, the DrGPCR University, and you will be our first professor professing starting in February. So Terry, thank you again for accepting to give the first course of the DrGPCR University. I would like to know if you have I know you have a couple of slides you want to show us, but I'm very interested if you can tell us and tell the audience what the course will be about.
Right. Sure. Well, the course roughly is about pharmacology, which is a unique science. Pharmacology is taught in every medical school. Med students get it, but what they get is therapeutics, not the kind of pharmacology that we are talking about here. This will be about making drugs, understanding how drugs work, how to improve them. It's the art of chemical control of physiology. So that's what this course is about. And it's not a common course that you take in schools. It's often a separate discipline, and for that reason, I think it could be useful for people in the field of discovery who have not come across pharmacology to get some basics, and that's what this course is about.
I think it's going to be fun. So just to give the audience a little bit more details, we start on February 8th. It's a Thursday. It's 4 consecutive Thursdays, starting at 10 a.m. Eastern time. And we have each class will be about an hour with a 30-minute Q&A. People who join will be able to take the course live. This will also be recorded. So anyone who has joined the class will be able to come back, get access to the recording, to any additional course materials, the slides, if you'll share with us, and they will also be able to get access to you. So I know you mentioned multiple times that you like it when students email you and ask you questions. So I hope that this course will get not only filled, but also people will come and ask you questions.
I do, yes. I've had students email me months after a course, and I enjoy that. I'm currently at UNC School of Medicine, but I spent most of my career in industry. So the course really is presented from the point of view of chemists, biologists moving compounds towards drug candidate status. So yeah, I appreciate interest from students, and I encourage questions at any time.
Amazing, amazing. And so the good news is that we designed this course so that anyone who signs up gets a 1-year complimentary access to the DrGPCR premium version of the ecosystem. So they can come back and find you in the courses group and reach out to you at any time, discuss between themselves as well. And upon the completion of the course, we will be giving a completion certificate to students, and students will be able to access not only the content of this course, but any content in the ecosystem. So I think it's going to be a really fun 4 weeks. I for sure will be attending because you can never get enough of refreshing your knowledge on pharmacology.
Well, so would this be a time I could show some slides to
Yes,
show the people the content and the kind of things that we will try to cover So I'll
Absolutely.
share my screen and I will. So I teach pharmacology to the graduate students here at UNC. Many of them don't know what pharmacology is. So when I introduce the courses, I use this slide, this analogy, and I'll use it here. So we can start with the question, what is pharmacology? If you equate the pure, quote unquote, sciences with purebred dogs, then pharmacology is the muddiest mud I could locate on the internet.
I love it.
Many of us come from these disciplines. We bring the ideas and the concepts from them towards one aim, and that aim is the chemical control of physiology. So we're interested in making drugs, curing disease, alleviating suffering, improving drugs, all that. And it's all using all the skills of chemistry, genetics, and so forth towards that aim. The thing about drugs that is unique and can be troublesome is they interact with physiology. And so what happens here is their profiles of activity change with the changing conditions of cell type, in vivo location, and so forth. So we need a way to predict activity. We do an experiment. That experiment can be considered a snapshot. So we get a reading of activity in EC50, whatever. But we can't take that as being this will be the activity in every organ that this drug sees. We need a way to project that to see the whole movie, which will be what happens when the drug gets in vivo. Pharmacology uniquely furnishes a bridge towards that. It can express activity in scales that are system independent, go beyond the tissue or assay where you measure the activity, give us scales of affinity, efficacy, and so forth. And these can be used to predict activity in all systems, including the therapeutic ones. So that's the value here. So this course it's 4 hours, as you heard. The first will be centered on what are the 4 parameters that describe all drug action in all systems. If you can understand these 4 things about your molecule, you can pretty well predict what it'll do in most systems. And those activities are the affinity, the concentrations that start to interact with your drug target. Efficacy, this is basically the change in behavior of your target upon drug binding, and efficacy has gone far beyond what it used to be. It used to be things like cyclic AMP, calcium, and so forth. Well, receptors have a wide range of activities beyond that, and we now have assays to look at those. And so we can now determine the efficacies that a compound has and their relative strength of activities towards them, so-called biased signaling towards those. So we'll talk about that. It's very important to know if your drug interacts at the common binding site of the natural hormone or transmitter, that is its steric hindrance at the orthosteric site, or it binds someplace else and allosterically affects the target. In the first case, your compound will hijack the receptor and impart its efficacy to the whole system. In the second, your compound will be a partner with the ongoing physiology, and this can give you a completely different profile of activity. So it's important to know which of these is relevant. Finally, kinetics. In vivo concentration is never constant. And so the real-time kinetics of interaction of your compound with the target is critical. This is target coverage. It will only do things while it's in binding to the target. And activity is really separate from kinetics. So it's something else you need to look at. So those are the 4 parameters. The first lecture will go over those. And then we'll talk about the 3 major classes of drug that you can have. Agonists, compounds that produce response, and antagonists. Mainly we'll start with orthosteric, competitive, non-competitive, partial agonists, inverse agonists, and finally allosteric compounds. This is a highly active emerging field in GPCRs, and we'll cover that at the end. And hopefully by the end of that, you will get some feeling for this idea of behaviors of drugs versus activities of drugs, behaviors being the changing activity you see with different systems. And hopefully you'll be able to answer questions such as this. Here we have a chemist, and he's interacting with biologists 1 and 2, who tell him seemingly different things. Your compound's a full agonist, partial agonist. Now, he's going to ask the question, should I care? And pharmacologists would be able to understand this and says, no, these are behaviors. There's nothing wrong here. It's to be expected. Your compound produces competitive effects. Your compound produces non-competitive effects. Should I care? No, in vivo, this won't matter much. And separate these questions from the questions that you really should know. Here we have, he's hearing your compound's allosteric, your compound's orthosteric. Should I care? Yes. One of these guys is wrong. This is a fundamental property of the compound, and it can't go both ways. So hopefully this course, by the end of the 4 hours and then the half-hour questions, that'll be 6 hours, you will have a feeling for these ideas and will be able to apply them. So I'll stop there. That's the summary I had of the course.
That is fantastic. I think it gives a really, really great sense to anyone considering to join, what it looks like and what should they be expecting. Lovely. Lovely. I think this was it. This was exactly what I was looking for. I was going to get into the different core topics you would be covering every week, but there's nothing to add. This is so fantastic. And I'm always amazed at the simplistic way of you explaining these things, when we all know behind the scenes with the numbers and the graphs and the data, it's so much more complicated. Yet you make it seem like a walk in the park.
Well, in this case, it comes from, I think, something like 45 years experience. So. Yeah.
Absolutely. Absolutely. Terry, thank you so much for your time. I cannot wait to have you on February 8th. Anyone who's interested in joining and signing up, please be on the lookout for the emails that are going to go out and social media posts. And hopefully we're going to have a great first successful DrGPCR University class with you on board.
Thank you.
Thanks, Terry. Don't go anywhere.